Hello everyone. Welcome to our new energy automation webinar, 7SS85, the ultimate busbar protection. First of all, I hope that you, your families and loved ones are safe and healthy. My name is Adnan Azmani. I am responsible for the energy automation product sales in the headquarters for Asia, Middle East and Pacific. And I'm happy that I will be moderating this webinar. And I'm happy also that I will be joined by two speakers. So before going into the heart of our webinar, I want to make sure that everyone can see and hear us. So please give us a feedback to the first poll that you can see on the right upper side of your screen. If you cannot see it and if you are using the full screen mode, please press escape so that you can see the poll. Please give us a feedback that you can hear and see us. Some other technical topics. So if you are facing any issue, just try to refresh your browser by pressing F5. And please note that it is better to use Chrome browser for this webinar. A wide connection would be better to use. And also if you have any VPN connection, so please just switch it off. Regarding the question and answers, you will be able to ask your questions through the whole webinar. And we will try to answer as many questions as possible during the webinar itself, so between the chapters and also by the end of the webinar. Please note that the recording and also the slides will be made available for download immediately after our session. And now let us move to the introduction of our speakers. And as I said, we have two speakers, and both of them are having a total of 60 years experience with Siemens. So our first speaker is Mr. Rainer Goblerich. Rainer is having a 30 years experience with Siemens. He started in development, first of substation automation system, LSA, and then in the development of the Dixie4, which is the configuration tool of the SIPROTEC relays. Then since 20 years, he started his journey with the Siemens busbar protection, first in development and then in project management, still in the development area, where his last project was the 7SS85. And then since 7 years, now he is the product manager of the Siemens low impedance busbar protection. Our second speaker is Mr. Matthias Schick. Matthias is also having more than 30 years experience with Siemens, and especially busbar protection. Actually, he started immediately by testing protection relay with focus on busbar protection. And actually, he had the chance to be testing but the first numerical busbar protection from Siemens, the 7SS50. It was a centralized busbar protection at that time. So busbar, okay. Matthias spent most of his time with Siemens dealing with busbar protection, first in testing, engineering, then in the sales department, and now he is a user consultant for busbar protection in Siemens headquarters, and he's supporting our customers, partners, and colleagues all over the world to make the best use out of our busbar protection portfolio. Without further ado, I would like to start now the heart of our webinar, and I would like to switch to Rainer. Rainer, the stage is yours.
Thanks for the introduction, Adnan, and hello also from my side. I hope you are all healthy. This is absolutely the most important in this COVID-19 area at the moment. In December 2020, we released the last missing step of the 7SS85 busbar protection platform. We can now also offer a distributed busbar protection for up to 45 current measuring points or base. This is a trigger for us to start a marketing campaign, not only for the new distributed busbar protection up to 45 measuring points, but for the whole application range of the 7SS85. Some words about the agenda for the webinar today. In the first chapter, I will give an overview about the 7SS85 busbar protection platform and about the general advantages. In the second part, Matthias will explain more about the application of being the successor of the 7SS52. But the 7SS85 is not merely the successor of the 7SS52, it is absolutely more. Afterwards, it will be again my part to talk about the application of an IC6150 compatible and interoperable solution. Before I will give a final system overview about the 7SS85 busbar protection, Matthias will present you the application of a cost-efficient enhancement of your grid resilience. With the release of SIPROTEC version 8.40 with a distributed busbar protection with up to 45 current measuring points, the SIPROTEC 5 busbar protection portfolio is completed now. We now have the ultimate busbar protection in our portfolio. But why is it the ultimate busbar protection? The SIPROTEC 7SS85 combines the proven, fast and secure algorithms of the 7SS52 with a flexible, scalable, open and user-friendly SIPROTEC 5 platform. The 7SS52 busbar protection is since more than 20 years on the market and more than 10,000 systems have been sold to customers all over the world. The 7SS52 busbar protection and especially its algorithms are very well accepted by all customers all over the world. And these, since more than 20 years approved busbar protection algorithms, are now combined with the SIPROTEC 5 platform. The 7SS52 is officially a SIPROTEC 4 device, but in reality it is a special designed device for busbar protection with a SIPROTEC 4 front end, and the bay units are even SIPROTEC 3 devices. This is different for the 7SS85 busbar protection platform. It is really fully integrated into the SIPROTEC 5 platform. Both the central unit and the bay units are full modular SIPROTEC 5 devices. So the ultimate busbar protection benefits automatically from each new SIPROTEC 5 platform functionality. This is especially a big advantage with regard to communication features and cybersecurity. Siemens is the only vendor who really can state according busbar protection. One platform, one device, one configuration tool for all your applications, voltage levels and busbar protection schemes. Thinking about e.g. ABB. They have the REP 670 for the centralized busbar protection and the REP 500 for the distributed busbar protection. They are different devices with a different philosophy of configuration. But the 7SS85 fits for all your system configurations. It fits for the centralized busbar protection. In the centralized configuration, all process information like sampled measured values of current and disconnector positions are directly connected to one centralized device. So here you can see it. In the centralized 7SS85 busbar protection is since beginning of 2014 on the market, and more than 3,000 devices have successfully installed in the meantime. And it fits also for the distributed configuration. In a distributed configuration, the process information is connected to the bay units. The bay units are nearly located to the process. This is especially important in a wide area air-isolated substation where a long distance wiring to the current transformers would lead to a high burden of the CT and therefore to an earlier CT saturation. The Bay units send the process information via fiber optics to the sensor unit of the distributed busbar protection. The first step of a distributed busbar protection, limited to a maximum of 20 current measuring points, was released with SIPROTEC 5 version 8.03 in January 2020. As already said, the second step with a maximum of 45 current measuring points was released in December 2020. Finally, for the first time in history, the new SIPROTEC 7SS85 supports also a hybrid protection, where the SIPROTEC 7SS85 will collect process information directly connected and through distributed Bay units. This is also available since January 2020. One platform, one device, one configuration tool. Let me explain the statement more in detail. The configuration of a busbar protection scheme always starts with drawing the substation topology in the Dixie 5 single line editor. Here in this example, you can see a double busbar with 2 feeders and 1 coupler with 2 current transformers. In the next step, the devices and all necessary elements inside the devices must be created. Here we can see the centralized configuration, where only the centralized 7SS85 must be created. And the base, the circuit breakers, and disconnectors and the current transformers inside the 7SS85 must be created also. In this slide, we can see the same for the distributed configuration. Here, the 7SS85 central unit has to be created, and additionally, also the Bay units. In the distributed approach, the circuit breakers, disconnectors must be created inside the Bay unit devices. In the third and final step, the device elements must be connected to the corresponding single line elements, either from the 7SS85 elements to the corresponding single line elements. You can see in this example, or from the 7SS85 elements, and mainly from the elements in the Bay unit to the corresponding single line elements. After this third step, the configuration of the topology, e.g. the number of feeders, couplers, single line or triple bus is done. Of course, the configuration has to be finalized by adapting the settings and routing the signals to binary inputs and outputs, which is common to all SIPROTEC devices. As final slide in this chapter about the general advantages of the 7SS85 busbar protection system, I will explain more in detail the benefits of the modularity of SIPROTEC 5. In the 7SS52 system, 2 types of Bay units were possible: the big 7SS5-3 and the smaller 7SS5-5. As backup feeder protection functionality, only circuit breaker failure protection, end fault protection, and non-directional overcurrent protection is possible. 1 current transformer can be covered with 1 7SS52 Bay unit. If a dedicated Bay unit is required, like in the 7SS52 system, the SIPROTEC 6MU85 is a right device type. The 6MU85 is a fully modular SIPROTEC 5 device. It can cover several current transformers and already offer several backup protection functionality for the feeder. Additionally to the protection functionality which is possible in the 7SS52 bay units, it offers also directional overcurrent protection, under and over voltage protection, synchronization, and an automatic reclosing function. In case feeder or line protection functionality like line or transformer differential protection or distance protection is required, also each other modular SIPROTEC 5 device can be used as a bay unit for the distributed busbar protection. For the communication between the central unit and the bay units, we are offering different topologies. First of all, we are offering a star topology like in the 7SS52 system. But to increase the reliability of your system, we are offering optional redundant communication between the central unit and the bay unit. At the moment, we can offer PRP as redundancy protocol. But we are already working on HSR as additional redundancy protocol. As soon it will be ready for the SIPROTEC 5 platform, it will be also available for the distributed busbar protection. By the way, in order not to confuse you, HSR is already available in the SIPROTEC 5 platform. But for the application in the distributed busbar protection, we need additionally the transparent clock and the current master clock functionality for the synchronization of the sampled measured values via IEEE 1588. So now I am done with the first chapter. Back to you, Adnan.
Thank you very much, Rainer. It's really impressive, and I am really happy that we can now offer such a unique solution to our customers all over the world. I mean, the fact that it is unique because with one platform, they can have centralized busbar protection, they can also have distributed, but for the first time also a hybrid solution. I'm already, actually, all the questions that we are receiving, we already received a lot of questions. We will have time to tackle most of them, definitely. Please do not hesitate to ask more questions using the Q&A box, which is at the right side of your screen. Again, if you don't see the Q&A box, you just have to press escape so that you can ask your question. Actually, you have to write it. Now, let us move to the next chapter, where Matthias will tell us a little bit more how we can use the 7SS85 as a successor of the well-proven 7SS52. Matthias, the stage is yours.
Thank you, Adnan. Okay, now it's my part to explain something about the application of being the successor of the 7SS52. But the SIPROTEC 7SS85 is not merely the successor of the 7SS52, it is absolutely more. This slide shows the single line diagram of a triple bus bar as an example. To equip a system with SIPROTEC 7SS52 busbar protection, one counted the number of current transformers, and thus knew how many bay units SIPROTEC 7SS52 were needed to cover. Then they selected a sufficiently large hardware version of the 7SS52 central unit, and that was it. Okay, after almost exactly 20 years, a life cycle of protection equipment, the 7SS52 successor for the distributed busbar protection, the SIPROTEC 7SS85, is now being presented. In a one-to-one migration, SIPROTEC 6MU85 merging units replaces the SIPROTEC 7SS52B units. And the SIPROTEC 7SS85 as a central unit replaces the SIPROTEC 7SS52 central unit. For a starwise communication layout, an Ethernet switch together with fiber cables establishes the communication between B units and the central unit. The user can assume that all technical parameters and functions, such as current transformer requirements or the amount of binary information from the substation, remaining unchanged. Well, that's it so far for the successor application. Now let's talk about the more. SIPROTEC 7SS85 is an adult member of the SIPROTEC 5 family. Almost the entire scope of hardware and functionality is thus available to the SIPROTEC 7SS85. With the SIPROTEC configurator, you can design your own customized hardware. This could be, for example, the B unit with the 2 current transformer inputs for the coupler bay. But this is only an example. You can place up to 8 measuring points in one bay unit. Here the distributed design more or less merges into a centralized design. The connection of the B units to the central unit can be done with redundancy protocols from the platform to increase reliability. This slide shows using the PRP Ethernet as an example. But that's not all about the more. Let me now talk about the scope of functions. A frequently heard question about the 7SS52 was whether the B units can have a distance protection function. Well, to be honest, we didn't get beyond an overcurrent protection function with the 7SS52. With SIPROTEC 7SS85, the question is completely different. Namely, which of the SIPROTEC 5 devices can also be the B unit of the distributed busbar protection? The slide shows the possibilities of either adding protection functions to the 6MU B units, here in this case overcurrent protection functionality, or making a modular SIPROTEC 5 device, which is working as a feeder protection, to be a B unit of the distributed busbar protection. SIPROTEC 7SS85 is available as a distributed busbar protection with functionality shared over several devices. The same is also available as a centralized busbar protection with a complete functionality in only one device. Here we have the centralized, here we have the distributed protection shown on the slide. Both hardware layouts offer specific advantages in direction or in direct comparison. By using a centralized variant and a distributed variant together, the advantages can be combined in a main 1, main 2 solution. In the case shown on the slide, the distributed main 2 is using additionally redundant communication with increased reliability. Each of you, I'm sure, has certainly heard the motto of the German architect Stefan Nitschke: time is money, space is money. If you look at this slide, you can see that with SIPROTEC 7SS85, Siemens has invested money to save your time and your space. Follow your operator philosophy and have a separate device for each function. Line protection, main 1 and main 2. Bay units for main 1 and main 2 busbar protection. And finally, a bay controller. Or combine the bay controller and bay unit main 1 and line protection and bay unit main 2 each in one device. Or even combine 3 functions: line protection, bay controller, and bay unit of the busbar protection in one device. The takeaways of SIPROTEC 7SS85, the successing solution of 7SS52 and more, are a simple and easy one-to-one migration retrofit of SIPROTEC 7SS52, together with a consequent reuse of busbar protection know-how and philosophy with up to 100%, plus adding advantages by winning time and space, saving money, and last but not least, gaining security from the use of SIPROTEC 5 platform. And now back to Adnan.
Matthias, I'm really excited because we are receiving so many questions, and actually I'm spending most of my time actually just trying to pick up the questions that I want to share with the whole audience, and also ask the speakers to answer. Before that, I would like to ask you to give us a feedback on the next poll. Again, you will see the poll on the upper right hand, and this poll is about whether you already have an existing 7SS52 system and you are interested in retrofitting this system into a 7SS85. Please let us know your feedback. And now let us take some time to answer some of your questions. Thank you very much. You are asking so many questions, and now we will try to answer some of them. And for this, Matthias, I will need your support, because I've seen it in one of your slides. This question is being answered in one of your slides. It is exactly the slide 28. So one of the participants is asking whether can you have redundant central units, means hot standby scenario connected to the PRP bay units. Matthias.
Yes. This is a solution which is foreseen in the SIPROTEC 5 platform. Mm-hmm. By connecting more than one central unit to a communication system.
Mm-hmm. Perfect. And actually, this is also what we can see in your slide number 28. I don't know if you would be able actually to share it, but in your slide 28, you are showing that we have redundant busbar protection. The first one, the main one, is centralized, means connected directly to the CTs, and the second one is a distributed one connected to the bay units. So this is a redundant scheme, and then we can also have another type of redundancy scheme where, is this the slide 28? Yeah, exactly. So yeah, please, Matthias, go ahead.
Sorry, Adnan.
No, I was saying that in this slide, in your example, you are showing a redundancy where the main one is connected directly to the CTs, and which is a centralized busbar protection scheme. And then the main two is a distributed busbar protection, which is connected or getting the sampled measured values from the bay units. But we can also modify this slide and put that both main 1 and main 2 are getting the sampled measured values from the same bay units. Is that correct?
Yes.
Okay, so
be careful. So here we have a centralized protection, which is not working together with bay units. So the centralized busbar protection is wired directly to the CTs, and it's gaining all the information also directly from the substation. So for that, it is not possible to use a centralized protection as a distributed or in a distributed layout.
Okay. No, I fully understand and agree. Thank you very much, Matthias. Now let us move to another question, and this one would be for Rainer. One of the audience asking, is 7SS85 adapted to centralized, distributed, and hybrid?
Okay, this question maybe will be more clear after my last chapter when I go more to the details of the different types of the 7SS85. But what is very important is to state that the basis, the algorithms which are located in the function group busbar are absolutely the same for the centralized busbar protection, for the hybrid busbar protection, and for the fully distributed busbar protection. But of course, we must adapt a little bit the existing centralized busbar protection with the communication stuff to be prepared for distributed busbar protection.
Okay, but still, the device, we can still use the same hardware. We just have to do some adaptations. We have to retrofit this device, add in the communication modules, and maybe also updating the firmware or the software.
The hardware is completely identical. So you can use an existing centralized 7SS85. It must be with the newest version of hardware, with the CB300, but I think that's quite long ago. Mostly the CB300 is used at the moment. And with this existing hardware, you only have to add a new communication module, and you can make a distributed busbar protection.
Perfect. Thank you very much, Rainer. So there's still a lot of questions. We will try also in the next chapters and also by the end of the webinar. So now let us move now to the next chapter, which is about the use of the 7SS85 as an IEC61850 compatible and interoperable busbar protection solution. So Rainer, please go ahead.
Thanks again, Adnan. In this following chapter, I will present the application of an IEC61850 compatible and interoperable busbar protection solution. Here, the main target customers are customers who have anyway an overall digital substation strategy. These customers are not merely interested only in a distributed busbar protection, but are interested in an overall IEC61850 compliant digital substation solution. Here we can see a simplified IEC61850 interoperable busbar protection. According to IEC61850, a redundant communication for a digital substation is mandatory. Here we see a redundancy via PRP. Oops, my mouse. Here PRP, here's the lane PRP-A and lane PRP-B. The reason is that in a digital substation, the communication is not only the precondition for one protection type, like in our webinar, the busbar protection, but for the whole protection, inclusive line and feeder protection. Therefore, a loss of the communication would lead to the loss of the complete protection. And as we will see this in the next slides. One of the biggest advantages of the IEC61850 compatible busbar protection is the possibility of the hybrid configuration. The typical application is that the 7SS85 sensor unit will be placed near to the bus coupler, and the process information of the coupler will be directly wired to the 7SS85. You can see this here in this coupler. Here we have the 7SS85 sensor unit, which is directly wired to the process information of the coupler. As there is normally no feeder protection necessary for the coupler, no additional device for the bus coupler will be necessary. According to IEC 60150, the interoperability of merging units from different vendors must be granted. So every third-party merging unit which is supporting IEC 61850 revision 2.1, that's very important, can be integrated into our busbar protection scheme. The SIPROTEC 5 process bus solution is the first vendor who is fully supporting IEC 60150 flexible streams. But of course, we are also supporting IEC 650-9-2 light edition streams, which is still necessary for the compatibility reasons for the third-party devices. In a fully digital substation, not only the busbar protection will be done with process bus, but also the feeder and line protection. In order to protect the transformer in bay E01, you can here see this transformer, we must extend the merging unit in this bay with an additional I/O module to collect all currents necessary for the transformer protection. This data will be digitized and sent via IEC 61850 communication, which means process bus for the sampled measured values, and goose for the binary information, to the additional transformer protection device 7UD87. All this can be done without affecting the busbar protection functionality. And also, an optional backup protection functionality like overcurrent protection can be added to the merging unit. Next step in our virtual road to a digital substation is adding a line protection. For bays which should be equipped with distance protection, the voltage information must be collected additionally. You can see here for these two bays, so we need additionally the voltage information. Of course, we need a line differential and distance protection device, e.g. a 7SL87, which have to be connected to the redundant Ethernet LAN. Two line feeders can be protected with this one 7SL87 device. The SIPROTEC 7SS85 can provide additional important binary information from the coupler for substation-wide interlockings. But a fully digital substation is of course not limited to protection. It includes also a substation communication, which must be built with a separate Ethernet LAN. Here you can see the IEC 61850 Substation Communication Bus. So you see here this green here, that's the station bus. And here we can see the process bus. We can also see a monitoring and automation and an interlocking, which is done via goose. An IEC 61850 compatible and interoperable distributed busbar protection, additional with the possibility of a hybrid configuration, is an integral part of a digital substation. So, the lessons learned from this chapter is as follows. We can offer an IEC 61850 compatible and interoperable distributed busbar protection, which can be fully integrated into a digital substation for monitoring, automation, and protection. Also, as IEC 61850 requires, third-party merging units as bay units can be integrated. Very important to state, the sampled measured values can be both captured by conventional current transformers and non-conventional instrument transformers, so-called NCITs. Okay, that was it. It's yours again, Adnan.
Thank you, Rainer. I think that the key takeaway message from this chapter is that we can have a seamless and easy integration of our busbar protection, the 7SS85 system, into a complete digital substation. So it's quite easy to integrate it into the process bus architecture. And that's why I would ask you, dear participants to this webinar, to give us a feedback to the next poll. So the question there is that, are you planning to implement a digital substation, and do you want to integrate the 7SS85 busbar protection into the overall busbar protection architecture? Thank you very much. The poll will still be there. You can answer it for the next minute. And now let us take the time before moving to the next chapter to answer some of your questions. So let me just move now to the question box. Rainer, this one is for you, and I think this concern is making sense, and it is good that we clarify it immediately. So one of the participants is asking, one of the concerns when using sampled values is the time synchronization. When the GPS clock fails or is manipulated, do you have mitigating measures? Busbar protection is very important. How do you assure us as users?
First important, very important to state is that we don't need the GPS signal to synchronize the sampled measured values. The GPS signal is only necessary to make also the real-time synchronization, which is important for the timestamp of the signals or fault records. Mm-hmm. Yes, but for busbar protection, we only need to synchronize the sampled measured values, and therefore we don't need the GPS signal. So that means if the GPS signal fails because of some reasons, the grandmaster clock will switch automatically to its internal clock, and that's without any effect to the function of the busbar protection.
Okay, so if we want to put it in other words, if the GPS is losing its connection to the satellite or is manipulated as it was described by the participant, this means that this will have no effect on the busbar protection.
Exactly.
Okay, very good. Perfect. Now let us move to the next question. So, this one is, maybe also Rainer, maybe you can answer this one. So, how many bays can be covered with one central unit in 132 kV double busbar scheme, with one breaker per bay and 2 section and 2 couplers included?
So most of all, it's important to state the maximum number of bay units or current measuring points does not depend on the voltage level, does not depend on whether you're using a single bus or even a triple bus bar or anything else. Mm-hmm. It's fixed for the centralized busbar protection. The maximum of current measuring points is 20. For the IC6150 compatible solutions, the maximum is 24. And with our newest distributed busbar protection, the maximum of current measuring points is 45. Mm-hmm. And as I said, in former times in the 7SS52, we could say, okay, the number of current measuring points is equal to the number of bay units. That is now different because in the 7SS85 busbar protection platform, you can cover up to 8 current measuring points within one bay unit, within one merging unit. So it's better now to count the number of current measuring points, the number of current transformers, instead the number of bays. So we have the limit now according to the number of current measuring points and not anymore about the number of devices.
Okay. No, quite clear. Thank you very much.
Thanks.
So this one is for Matthias, and this will be the last question before moving to the next chapter. So Matthias, is it possible to install redundant central unit, for example, in redundant buildings? And I think this question is also somehow related to the maximum distance that we can have between the bay units from one side and the central unit from another side.
Yeah, so for the communication, we need our Ethernet BD 2FO module, and this module bases on communication modules which are ready to transfer up to 2 kilometers. Mm-hmm. So if you compare this with a 7SS52 and 7SS52, the maximum distance between bay unit and the central unit was limited to 1.5 kilometers. Means with our new solution in SIPROTEC 5, we are on standard extending the distance between a bay unit and the central unit up to 2 kilometers. Mm-hmm. But this is not all. This so-called SFP modules may be exchanged. So you may have also SFP modules or communication interfaces which are able to transfer up to 10 kilometers.
Mm-hmm. Okay, so it will be single mode.
Yes.
Mm-hmm. Okay.
I remember an application where a substation was partly on the right hand and on the left hand side of a river. It was an interesting application, and the maximum distance of 7SS52 was used completely. So I think for SIPROTEC 5 based busbar protection, it will not be a problem. So with the chance to exchange this SFP modules from 2 to longer distance, like 10 or 60 kilometers, the rivers may extend in their wide.
Okay, it will be quite an interesting application to see how those redundant buildings are far away from each other. But anyway, I think that 10 kilometers is more than enough. Thank you very much, Matthias.
Welcome.
So now let us move now to the next chapter, where Matthias will actually give us some details about a new use of busbar protection in a field where normally we don't have busbar protection, or maybe we had high impedance busbar protection, but not low impedance. Here we're talking about the medium voltage switchboards. We're talking about your sub-transmission substation, and also about the industrial grids. So Matthias, please share with us how our customers can increase the reliability of their grids by using busbar protection in such voltage levels. Matthias, stage is yours.
Thank you, Adnan. Okay, in this last chapter, before the system overview, I will talk about the most difficult application of our 7SS85 busbar protection. The application of a cost-efficient enhancement of the grid resilience. Here, the target customers are in the industry, medium voltage or sub-transmission and distribution area. This sphere of business is very cost sensitive, and therefore today mostly not equipped with a dedicated busbar protection. Here on the slide, we can see the example of a typical industrial power grid. The busbar is framed blue. It is a double busbar with a sectionalizing coupler in the middle. There is one in-feed for each section of the double busbar available. Here, one on the left hand, one on the right hand side. And we can state from this central double busbar, the whole grid is supplied with power. Without a dedicated selective busbar protection, a busbar fault would lead to the loss of the complete central busbar. This would lead to the shutdown of the grid. A dedicated busbar protection can selectively trip only the affected bus zones, and it would be possible to maintain the power supply of the grid by the remaining healthy bus zones. Therefore, a dedicated selective busbar protection is proposed to enhance the resilience of the power grid. Let's have a look to the details of such an industry or sub-transmission power grid. The slide is not showing a real power grid. It should only demonstrate the principle. The feed-ins and consumers are already equipped with SIPROTEC 5 protection devices. Here, the transformer with a 7UT85, for instance. There can be already a motor protection 7SK85 for to protect this motor here. And in a distribution grid, there can be already protecting a line differential protection 7SL86. And here on the right-hand side, a feeder protection equipped with an overcurrent protection device 7SJ85. It is easy to enhance a grid with a cost-efficient busbar protection. You only have to add Ethernet BD 2FO communication modules to the existing SIPROTEC 5 devices, one per each. You need, naturally, some additional function points in the existing devices to activate the per-unit functionality. Of course, you need an additional SIPROTEC 7SS85 busbar protection as a central unit. And finally, you have to build up an Ethernet LAN and connect all devices via the Ethernet BD 2FO modules with this LAN. This is shown here in the green color. Now you have a dedicated selective busbar protection integrated with the existing feeder protection devices. So the summary of this chapter is as follows. With the possibility that each modular SIPROTEC 5 device can also enhanced to be a B-unit of the distributed busbar protection, a busbar protection functionality can be seamless integrated into SIPROTEC 5 protection. This allows cost-efficient busbar protection. So that's all for this chapter. Back to Adnan.
Thank you, Matthias. What an interesting, flexible solution we are able now to offer to our customers all over the world. Dear participants, please give us a feedback on the next poll, which is related to this chapter. So are you interested in increasing the resilience of your grid, maybe medium voltage, sub-transmission or industrial grid, by using cost-efficient busbar protection solution? Once again, the polls are on the right upper side of your screen. Now let us try to answer some of the questions that you have asked. Okay, this one is for Rainer, because I think that you have already mentioned it, but maybe we can again answer this one. So one of the participants is asking, can it accept, means the 7SS85, can it accept other relays like ABB or GE as bay unit for process communications?
Yes, we can accept, but of course we can't accept every device. If it is an IEC61150 compatible device which supports revision 2.1, then it's possible to use any competitor device as a merging unit for the IEC61150 compatible busbar protection. But it must support, it must be process bus-like conform, and it must support the revision 2.1.
Okay, understood. It's quite clear. Now another question, how many sampled value streams does the merging unit support?
At the moment, that's general for the general busbar solution. One merging unit with one PD module can support one stream.
Mm-hmm.
So that can support two streams. One PD module can support two streams. That's for the IEC61150 solution. If we are going a little bit into the detail for the distributed busbar protection for up to 45 current measuring points, we are supporting at the moment only one stream, but this is a flexible stream, and a flexible stream supports 8 analog values. So that means one merging unit with one stream can deliver up to 8 current measuring points to the central unit 7SS85.
Okay, understood. And when you are saying that it is one BD module having one stream, it means that can we add other BD modules and then increasing the number of streams?
Yes, for sure.
Okay. And so how many maximum?
Maximum would be four BD modules.
Okay, so
but I think normally that's not feasible for the merging unit. Because normally you don't need the number of BD modules will be more interesting for the 7SS85 center unit. But this I will explain after my final slide.
Maybe. But just trying to give the maximum capabilities of the system. So definitely, if the customers wants to have more streams sent from the merging unit to the central unit, then we can use more BD modules. Correct?
Yes, exactly.
Okay. Very good. Then another question. Is it only way of processing? I'm trying actually to read exactly the question, how it is being raised by the participants. Is it only way of processing BI and BO is GOOS for the distributed systems? In other words, in order to exchange the BI and BO's binary inputs and outputs between the merging unit and the central unit is the only way by using the GOOS communication, the 61850-8-1 GOOS communication.
In our distributed busbar protection for up to 45 current measuring points, because that's a lot of communication signals necessary. All binary information which is necessary for the busbar protection, that means the disconnector, position, the tripping signal from the center unit to the bay units, the handshake for the end-fault protection and the circuit breaker failure protection will be done automatically. This communication will be done automatically by the system. But it's possible to have each signal in parallel also to connect manually by GOOS.
Okay.
So the result for the distributed busbar protection up to 45 current measuring points, no GOOS signals are necessary for the distributed busbar protection. But if for some other clients, for some other devices, some of the signals will be necessary in parallel via GOOS, that's possible also. Okay,
perfect. And as far as we are still in the communication side, and actually this is a question from my side. So if we want to send some information or some data directly from the bay unit to the substation automation system, can we connect the bay unit directly to the station LAN? I mean, separately with a separate communication module?
Yes, for sure. It's all bay unit, all merging unit can have two PT modules, and so one PT module for the process bus LAN and a second PT module for the substation communication LAN.
Okay. Actually, your answer is bringing me to another question from one of the participants, because you are talking about bay unit, merging unit, bay unit, merging unit. And actually, one of the participants is asking, what is the difference between bay unit and merging unit?
That's a very good and not so easy question. When we go for distributed busbar protection, which is mainly based on process bus technology, and the naming for bay unit in the process bus technology is simply merging unit. Yes, but after 20 years or 30 years distributed busbar protection, the merging unit for distributed busbar protection is called since 30 years bay units. So from my point of view, it's a little bit a synonym in the meantime. But for the distributed busbar protection, for the completed distributed busbar protection up to 45 current measuring points, we are saying, okay, we are still remain on the name bay units, but we're using for the bay units the SIPROTEC 5 device type 6MU for merging unit 85. So you can see it's a little bit a synonym. But if we are going more in the area of the IEC 61850 compatible solution, and here for in IEC 61850, we are talking a little bit more about, okay, we call it more the merging unit.
At the end of the day, those are synonyms. So a merging unit is a bay unit. Bay unit more in the field of busbar protection, and merging unit more in the field of digital substation.
Yes.
Okay, last question before we move to the next chapter, and this one will be for Matthias, if you don't mind. Quite a tricky question, but I think that you'll be able to answer it. So, is the 7SS85 reliable enough like the 7SS52? What I like in this question is that the customer is already confirming that the 7SS52 is quite a reliable busbar protection. And now he's asking whether the 7SS85 is also as reliable as the 7SS52. Matthias.
Yeah, very, very good question. I think so. To make it short, so I can give a short answer, and the short answer is when 7SS85 busbar protection was developed, the only one requirement specification was developed a SIPROTEC 5 busbar protection, which is 7SS52. So to bring it on the point, we are using the same well-proven algorithms coming from 7SS52 inside of 7SS85.
Okay, so it's straight. And
means the reliability is more than equal.
So with the 7SS85, we can have even more reliability than the one that we are having with the 7SS52. And actually, this is mainly based on the fact that we are using the same algorithms and exactly the same algorithms. And in addition, with the 7SS85, we have more communication capabilities to have a reliable communication. Yes. With the SS52, we only have the possibility to have a star communication between the bay units and the central unit. And now with the 7SS85, we can do exactly the same, a single star connection, but we can also do more going towards the PRP, parallel redundancy protocol, where we have redundant networks, which will increase the reliability of the communication between the bay units and
the central unit. Correct.
Okay,
thank you, Adnan.
I'm trying also to partially answer.
I couldn't explain it better.
Thank you very much, Matthias. Okay, so as I said, this would have been the last question before moving to our last chapter. Rainer will give us more details about the 7SS85 system overview. Rainer, we are virtually yours. Go ahead.
Okay, thanks for the last time, Adnan. Okay, let's come to the last chapter. Here I will give you a general overview about the 7SS85 busbar protection platform, but also explain some interesting details. According to the application range, simply can be stated, each application which is possible in reality can be covered now. From the simple single bus up to a triple bus with 2 transfer buses and more is possible. And of course, all the special applications like breaker and a half, ring bus, and so on, which were already possible with the first version of the centralized 7SS85 are still possible. In the following slides, I will a little explain about the differences of the different types of the 7SS85. In the first step, the 7SS85 was only a centralized busbar protection. These types are defined by the significant feature or significant properties, we are calling it sometimes 9 and A to E. For example, the significant feature 9 means only 1 zone. Significant feature D means 6 zones and disconnector image. This allows to adapt the scope of the device functions near to the application case. There is the function group busbar in the 7SS85. Here we can see the function group busbar. With the function block checked zone and 1 function block bus zone for each bus zone in the primary substation. The busbar differential algorithms are located in the function group busbar. For each feeder or coupler bay in the primary substation, a function group bay in the 7SS85 is necessary. In these bays, the function groups for the circuit breaker, the disconnectors, and the current transformers are located. For an additional backup protection functionality like directional overcurrent protection and voltage functions, also a function group voltage current can be created. All process signals are directly wired to this central 7SS85 device. Here you can see. With version 8.03, with the release of the SIPROTEC 5 ProSex bus solution, the first step of a distributed busbar protection was available. It was limited to a maximum of 20 current measuring points. This number could be extended with some restrictions to 24 in version 8.30. We call it the centralized busbar protection using IEC 6150 compatible distributed process connection. Here the same 7SS85 types are used as in the centralized configuration. The structure of the proxy elements in the 7SS85 is completely the same as in the centralized configuration. But the process signals are not wired to the central 7SS85 device, but to the merging units located nearly to the process. From the merging units, the sampled measured values will be transmitted by a IEC 6150-9-2 via the process bus to the 7SS85 sender unit, where the binary signals will be exchanged via IEC 6150 MMS goose between the merging unit and the sender unit 7SS85 over the same local area network. The hybrid configuration is simply a mix of the centralized busbar protection and the centralized busbar protection using IEC 6150 compatible distributed process connections. Some bays are connected to the process signals via merging units. Other bays are directly wired to the process signals. Here, this example. Finally, let's come to the distributed busbar protection up to 45 bays or current measuring points. Here are different significant features of the 7SS85 applicable. The function group busbar, including the busbar differential algorithms, are completely identical to the function group busbar in the centralized busbar protection. All process signals must be wired to the bay units. There is no hybrid configuration possible in the distributed busbar protection up to 45 current measuring points. In the 7SS85 center units are only proxy elements derived from the full function groups and functions in the bay units available. These proxy elements contain the important signals and settings from the bay units regarding busbar protection. The proxy elements need a reduced amount of memory compared to the full function groups and functions in the centralized 7SS85. This reduced memory consumption is necessary to reach the goal of up to 45 bays or current measuring points. I don't want to go too much into the details of this system overview. In the first column, the different system features can be seen. In column 2 and 3 and 4, you can read the specifications for the 3 different types of the 7SS85. Here's the central 7SS85, the IC6150 compatible distributed solution, and the full distributed protection for up to 45 current measuring points. Important are the following rows. The number of bus bars is 3 for the central protection types and 6 for the distributed types. The maximum number of current measuring points is 20 for the centralized protection, 24 for the central protection IC6150 compatible, and 45 for the distributed solution. The maximum number of busbar is 6 in the centralized types and 20 in the distributed busbar protection. Also, I don't want to go through the complete list of functions available in the 7SS85. They are simply too much. But let me mention and comment the most important features. As in each Siemens busbar protection device, a disconnector independent check zone as an additional tripping criteria is available. This is additional to the 6 or 20 selective bus zones. We are really proud about the tripping times of the 7SS85 busbar protection. A high current internal fault will be cleared by the centralized busbar protection within 7 milliseconds. This time is already including the delay time of the Type F SIPROTEC 5 binary outputs. The tripping time of the distributed busbar protection is only a little delayed by the necessary communication. Here, the typical tripping time of a high current internal fault is 8 to 9 milliseconds, including the delay time of the Type F binary outputs. The highlights on these slides are the additional sensitive characteristic for fault currents smaller than the load currents. This application has proven itself over 25 years, for example, for the detection and tripping of single-phase fault in resisting grounded networks. Furthermore, the 3 interacting self-adapting measuring methods achieve the shortest tripping times for internal faults on the one hand, but also a very high stability for external faults, even with large short circuit currents. Also, a high remanence values are tolerated, and a current transformer saturation will be bypassed by the self-adaptation. And here's a highlight on the next slide. In your plant, it is important to be able to deal with special operational conditions in addition to the daily operational management. And this must be ensured safely and trouble-free. Whether cyclical tests of the feeder protection devices, maintenance work on switchgear, technical conversions or extensions of the system, the goal is to achieve operations that is as reaction-free as possible along with maximum protective function. Various control options such as bay out of service, acquisition blocking of disconnectors and circuit breakers, simple blocking of protective zones, or circuit breaker failure protection optimally supports your activities. So now quickly, the last three important points of view about the SIPROTEC 7SS85. At first, whether arc protection, pressure box, or external breaker failure protection, in the end, all feeders of the affected busbar must be tripped. To do this, use the function direct tripping of protection zones by external signals with the integrated disconnector image. Secondly, the integrated coupler bay protection for couplers with two current transformers. This makes selective tripping possible, but that is not all. It still has to be fast. If it still has to be fast to ensure grid stability, the coupler bay protection can dynamically switch to a non-selective overlapping protection of the coupler depending on the fault current magnitude and the type of fault, which means phase-to-ground fault or phase-to-phase fault. And last but not least, a security package with extensive cybersecurity functions such as role-based access control, airbag, logging of security relevant events, signed firmware, or authenticated IEEE 802.1x network access. So we are now finished with the slides. Thank you very much for your attention, and back to Adnan.
Thank you very much, Rainer. We are still with the audience, and I just want to make a remark. There are some slides that Rainer just made some comments about them, and there are a lot of topics which are mentioned there. Please note that the slides and also the recording will be made available for download. So you will be able actually to read all those points at your ease. So now let us go again with some of the questions that you have raised. Actually, we have more than 100 of questions. Definitely, we won't be able actually to answer all of them, but as I said, we'll try to answer as much as possible, but then afterwards we will be answering each and every question individually. So you will receive an email from our experts. I'm trying to find now the questions that I was highlighting. Sorry, just... Okay, Matthias, this one is for you. Can we have CT supervision function in each bay of a 7SS85 central unit?
Yes, in each bay, naturally, not in the central unit, but the CT supervision is integrated part of the reliability system of the busbar protection. So you have CT supervision for each CT connected to the busbar protection.
Thank you very much. Rainer, this one is for you. After 10 years, for example, is it possible to easily and safely build a new bay unit to the installation and integrated the whole system?
Yes, of course. That's the same like in the 7SS52. The system can easily be extended by additional bay units. So even we do not have the disadvantage like in the 7SS52, where each communication module SK can communicate with up to 8 bay units, and if you succeed the number of 8, and each SK module is filled up, and you have to order a new extension of the sender unit also, that's not necessary anymore in the 7SS85. You can just to add it. Maybe you need a new communication module if you have more than 15, 30, or more than 15 or 30 bay units. Yes. So,
and maybe also you need to maybe extend your communication switch if you don't have other ports available.
Yeah, okay, thanks. I forgot, maybe if you get lost at the moment with our PRP solution, we need the Ethernet switch, and if you're out of ports in your switch, you need additional switch, but with the upcoming HSR solutions, this will be not necessary also anymore.
Okay, perfect. Matthias, back to you. In case of fail of one, in case one of the bay protection relays or the bay unit is failing, what happens for the busbar protection? Would it be blocked?
Yes, good question. But here again, we can compare the 7SS52. So we have the same philosophy to keep as much protection available as possible. So if one of the bay units fails, only the directly affected part of the system will be blocked, and the rest, which is not affected, is still protecting and working as expected.
Okay, perfect. Matthias, please stay with me. One of the participants is asking 45 single phase current measuring unit, or is it a 45 three-phase current measuring unit?
It is a 45 three-phase measuring.
I could have answered it myself, but
yes,
just asking you because you are official.
Even to say not only three-phase, it's the three phases plus the neutral current every time.
Yeah.
Yes, which is important for the supervision functionality as well. Yeah. This is again one of the points with which we can compare with 7SS52. We kept our fast current sum supervision to make sure that the busbar protection based on SAMBIT measured values will not behave unexpected with disturbed measured values.
Maybe one additional information, Matthias, as you said here, the CD supervision, it's important to add, maybe you forgot, we have, without any configuration by the customer, in the central unit for each measuring point, an automatic fast current sum supervision in additional, which will automatically block the busbar, the affected busbar protection zones if something is wrong with the current information. So we have CD supervision both in bay unit and in the central unit.
Okay. Thank you, colleagues. I'm trying. Okay, there is a comment, but maybe you can also. It's not a question, but just a comment. But maybe you can also extend it. So, bus coupler differential protection was really new invention to avoid the unfaulted zone to trip. Maybe one of you can comment on this one.
Yes, the bus coupler differential protection was invented, I think, 3 years ago. It's the first step, of course, only for the centralized busbar protection. And we invented it together with a customer in Australia. We did a lot of studies also what additional functions would be necessary, and here we come to the resolution that an automatic switch from the selective tripping to an non-selective switching in the overlapping mode, like it is used to be done in the 7SS52, which depends on the level of the fault current, and also whether it's an phase to ground fault or whether it's an phase-to-phase fault. Because we learned during the study that for very high current phase-to-phase fault, it may be better to switch very fast but unselectively. And therefore, we add to this bus coupler differential protection also some settings to switch automatically to a non-selective overlapping trimming. So that's a very interesting. If somebody is interested in more deals, he can contact me directly, and I will forward some papers also about this topic to him.
Okay. Yeah. For that question, there's also a remark from my side. So first, I would like to say, okay, there was a solution for the bus coupler differential protection also implemented in the 7SS50. So in the early beginning, and we have had also an application using a bus section in 7SS52. But I have to highlight what Rainer was mentioning. The bus coupler differential protection in 7SS85 is from a new quality, because it is not only the functionality for a sequential tripping. The highlight is that we are able, and I can't say it often enough, we are able to switch over between bus coupler protection and the overlapping scheme, deciding while the fault takes place. So this is a very dynamic switching over between the bus coupler protection and the or the overlapping protection, which is unselective but fast. So, and from my knowledge, Siemens is the only vendor providing such functionality, and this is, I think, important to be highlighted.
Okay, perfect. Thank you very much, Matthias. Before going ahead with the other questions, I would like to ask the participants to answer the last poll. It is about the webinar itself. So please let us know how interesting you find our webinar. So we are looking forward to your answers. Let us look for another question now. Okay, Matthias, which busbar protection type is more safe against CT saturation problems? Is it the centralized one or the distributed one?
So, yeah, difficult to be answered. So there is no relation to the centralized or the distributed layout of the busbar protection, because the same algorithms are working inside. So basically we can state that there is no difference between the centralized and the distributed layout of busbar protection. But maybe this question is going to this direction, that the connection or the needed copper connection between a CT and the centralized may be longer than the connection way of a distributed protection, where the bay unit is placed near to the CT, which is limiting the CT burden to a lower level.
Yeah, this is obvious. Yeah. Okay, thank you, Matthias. I just want to make a comment on one question here. Could I contact you directly? What is your contact details? Actually, in the last slide, or one of the last slides, you will see the contact details of our both of our experts, Matthias and also Rainer, and definitely you can contact them directly. Rainer, this question is for you. Can I use any module other than the 6MU as a bay unit, like a feeder protection or a transformer protection?
Yes, of course, you can use any SIPROTEC 5 modular device also as a bay unit for the distributed busbar protection, as already mentioned. So you can use a 7SJ85 and 7SL86, 87, so whatever is possible.
Okay. Yeah, I am a little bit overwhelmed with all the questions that we are receiving, and to be honest, I'm not even able now to pick any of the questions, and I'm a little bit, also excited to answer all those questions afterwards. So, last but not least, actually, I want to thank Matthias and Rainer. Thank you very much for the time you have given to the participants to give all those details about the new 7SS busbar protection. And now I think that the whole audience understands why we call it the ultimate busbar protection. To the audience, thank you very much for your attention. it was a real pleasure for all of us to have this webinar with you, and we hope that we will see you very soon in one of our next webinars. Thank you very much, and stay safe and healthy, and